Hey Griffin, how you doing?
Good, how are you?
Good. So what are we looking at tonight?
We have been doing parametric equations and
Okay.
things related to that.
All right.
So this is just asking to sketch the curve,
Okay.
and it's x equals 1/4 t, and y equals t squared.
Okay. So the best way to sketch these, do you have a domain on T?
No.
No? Usually when you're dealing with parametric equations, you have a domain on T. Like T can go from 0 to 5 or 2 to 4 or something like that. If we don't have that, well then the easiest way to sketch this is to solve both sides for T and then plot that. In other words, if x equals 1/4 t, then t is equal to 4x, and square root of y plus or minus equals t over here. So if t is equal to that and t is equal to that, then I can set 4x equal to that. Now if I square both sides, I get y equals 16x squared. That we know how to graph.
Yeah.
That's a simple parabola at the origin, very steep, like that.
Alright.
Now, there is another way to graph these, and that is to think of t as counting from something. In other words, in this case, if I let t go from, say, -4 to +4, then the way that would play out would be when t is -4, x is negative, and then as t counts forward, it goes like this. And with parametric equations, you actually have a direction on the thing. In other words, if you were to plot this parametric equation in your calculator, it would come out looking like this. It would start here, and it would travel like this, and you would see it in real time doing that. In other words, it would go in that direction, not the other direction. And that's kind of a crucial thing about parametric equations that makes them unique, kind of. What else you got?
Do x equals 4 sine of 2 theta, y equals 2 cosine 2 theta.
Oh boy, you're going to make me work for this one. All right, whenever you have trig functions in your parametric equations, it becomes more difficult to solve for the third parameter. In other words, if I want to solve for theta here, it's awfully tough to do. And solve for theta there, and then I would have an equation that was just x and y. There's a better way to go here. Whenever you have parametric equations that involve sine and cosine, then the best thing to do is to square both sides right off the get-go.
Okay.
All right. Now, as with any equations, I'm allowed to add them together. I can add this equation to that equation. Or subtract them. Well, if I add them, I get x squared plus y squared equals 16 sine squared of 2 theta plus 4 cosine squared of 2 theta. Boy, you gave me a tough one. This is an ellipse, I'm sure.
Okay.
But usually, these are hard to solve. I'm not quite sure I know how to do this one. Usually, I'm sorry to do this, but let's back up a moment. Let me change this number. And then I can show you how to do it properly. And then maybe we can figure out how to do an ellipse.
Okay.
Okay? Let's make it x equal 2 sine of 2 theta and y equal 2 cosine of 2 theta. So x squared becomes that. Now I have a 4 there. I can factor out that 4, leaving behind sine squared of 2 theta plus cosine squared of 2 theta. Well, what's that equal to?
1.
1. Sine squared x plus cosine squared x is equal to 1. That is your standard trig identity. The fact that it's 2 theta does not matter. In other words, the sine squared of any angle plus the cosine squared of that same angle is always equal to 1.
Okay.
So now I can replace that whole thing with 1, and I have x squared plus y squared equals 4, which is the equation of a circle of radius 2 at the origin.
Mm-hmm.
So, the problem you gave me, I've seen this before, and I have not known how to solve it before. So maybe we can figure it out.
Okay.
How can I pull that sine squared plus cosine squared out so that I'm left with x squared plus, or x squared over some number plus y squared over some number equals 1, which is the equation of an ellipse. I know this is the equation of an ellipse because this number is different than that. If it was the same, it would be a circle. But therein lies the problem. I've never figured out how to factor this out. If we say factor, what happens if we factor this out? I don't know what to do from here. I can't figure this out from here. I would love for somebody to show me this. None of my books have an example of an ellipse that's in parametric form. So I've never been able to look this up as to how to do this. I suppose I could try using double angle stuff. In other words, I don't know what to do next. I cannot pull out a sine squared plus a cosine squared.
Mm-hmm.
If I could replace it with 1. Let's see what happens if we use the double angle formula. Maybe something nice will happen that we're not aware of. Well, sine squared, let's see, the sine of 2 theta is 2 sine of the double angle formula for sine is 2 sine of, what the heck is it? sine theta, cosine theta. And the cosine squared can be written in one of three different ways. Which way am I going to want to write it? Probably it's 1 minus 2 sine theta, or it's cosine theta minus 1. It's cosine squared theta minus sine squared theta. Does that get us anywhere? It's and then we have to square all that also. I don't know. Can we set this aside? I hate to waste our whole session on it when I don't know how to do it. And
Yeah, sure.
I will put some effort into figuring out how to do this before we speak again.
Okay.
What else you got?
We've also been doing like polar equations and polar coordinates and converting those.
Okay.
So this is convert the point to polar coordinates, and it's negative root 3 comma negative root 3.
So those are the xy coordinates.
Mm-hmm.
We want to convert them to polar coordinates, which are r comma theta.
Mm-hmm.
And we have some equations that we know. X equals r cosine theta, correct?
Mm-hmm.
Y equals r sine theta, and r squared equals x squared plus y squared. So, what is r? R is x. So if I do a direct substitution here, I get minus root 3 equals r cosine of theta. And I get minus root 3 equals r sine of theta. And the last equation we need is theta equals the inverse tangent of y over x. Those are the four equations we're going to use when working with polar coordinates.
Yeah.
So, what's theta?
Theta is going to be inverse tangent of negative root 3 over negative root 3.
Yeah, this actually gets a little complicated, which would be 1. But that's not really theta. Sorry about that. Theta is the inverse tangent of y over x if x is greater than 0. But theta is the inverse tangent of y over x plus pi if x is less than 0. And look at that for a moment. That's very strange. In other words, we don't care what y is. We only care what x is. Well, in our example, y over x was negative square root of 3 over negative square root of 3, correct?
Yeah.
Which is equal to 1. So, but if I look up theta is equal to the inverse tangent of 1, I will get 45 degrees, and that's not the answer. It's 45 degrees plus pi. In other words, it's 225 degrees. Why? Because x is negative. That's the only thing that matters. If x is negative, I have to add pi to that result.
Yeah.
So theta is 225. What is r? Well, r is relatively easy. R squared is x squared plus y squared. So we have r squared equals square root of 3 plus square root of 3. That's x squared, excuse me. It's 3 plus 3, right?
Mm-hmm.
So r squared is 6. R is the square root of 6.
Okay.
So this converts to square root of 6 comma theta is what? It's 5 pi over 4.
Mm.
You usually want to give it in radians, not degrees.
Okay.
Okay, what else you got?
And this is converting the rectangular equation to polar form.
Okay.
And the first one is y equals 4.
Okay, well we know y is equal to r sine theta. We also know that that's a vertical line. In other words, I'm sorry, it's a horizontal line. That line right there. So it's going to actually be a more complicated polar equation. So we have 4 equals r sine theta. Y equals 4. Thinking for a moment. It's been a while since I've worked with polar coordinates. You're my first pre-calc student that's hit polar coordinates.
Oh, really?
Uh-huh. This year. I mean, I've worked with them a lot in previous years. But let's see. So, let's see. 4 equals r sine theta. That doesn't help. However, I know that theta is the inverse tangent of y over x. So it's the inverse tangent of 4 over x. Y equals 4. 4 equals r sine theta. So I suppose I could say 4 equals r sine of inverse tan of that. Doesn't help much. Do you have answers on these?
Yeah, let me check my book real quick.
What's your answer say on this?
Page 7.
I'm trying to call you, but you feel like your hand is. I'm going to hang up and call back, but you answer the phone. Okay? Love you. Bye.
The answer is... one sec, I lost the question number. 35. R equals 4 cosecant theta.
That's what r is equal to?
Yeah.
In other words, don't we need an r and a theta?
I don't know. Could you excuse me 1 sec? I have
Sure.
to answer the phone.
Sure, go ahead.
All right.
All right.
Yeah,
Let me go over this problem I have in the book, and maybe we can figure this out. Here I'm going to convert polar to rectangular.
Okay.
First thing I'm going to, excuse me, there's a 4 here. First thing I'm going to do is divide both sides by secant of theta.
Mm-hmm.
Which means that r cosine theta, because that's the inverse of secant, equals 4.
Yeah.
Well, that means x equals 4, because x equals r cosine theta.
Mm-hmm.
So that equation would be x equal 4. It's a vertical line. So the vertical line x equal 4 ends up, we're changing an equation. We're not changing coordinates. That's where I got confused.
Oh, yeah, I got confused there too.
Because you got two processes with polar coordinates. You can change a set of polar coordinates to rectangular coordinates. You can change a set of rectangular coordinates to polar coordinates. And you can take a polar equation, change it to rectangular, or vice versa. So, if we had the equation, what was it, y equal 4?
Yeah.
So I could say that since y equals sine of theta, I need r to be 4 cosecant theta? Yeah.
Mm-hmm.
Because then 4 would equal r divided by cosecant theta, which is the same as r sine theta equals 4.
Mm-hmm. All right.
So r sine theta equal 4 is the same as y equal 4.
Okay.
Now, some of these things you have to be takes a little bit of out-of-the-box thinking.
Mm-hmm.
And I'm sure that that's what's required on that ellipse. I need to see an example of how somebody does that problem.
Yeah.
And I'm not kidding you. I've looked at that problem for 2 years. I get it about once a year, and I've never figured out how to do it.
All right. The next one's pretty similar. It's just x equals 10.
See why I got that?
Yeah.
Because secant of theta, 10 is going to equal r divided by secant of theta. And secant of theta is the inverse of cosine. So now I have r cosine of theta equals 10, and r cosine of theta is x.
Mm-hmm.
So this and this are the same.
Okay.
I have a
Still same thought.
particularly interesting one if you're looking for something different.
Mm-hmm.
Convert this to a polar equation. not too many first steps that you can take other than the obvious one, which is to what? Expand it.
Yeah, yeah.
Okay. And then combine, and you kind of want to put the x squared and the y squareds together.
Mm-hmm.
And the numbers, and put everything on the left. Well, now we can substitute r squared for that, and r cosine of theta for x, excuse me, so this becomes 6r cosine of theta, and sine theta for y, so that becomes 4r sine theta. The reason I introduced this problem is because it's pretty exotic. Now, if you factor out an r here, you get r times r minus 6 cosine theta minus 4 sine theta equals 0, which means now we have to solve this. That means either that's 0 or that's 0.
Mm-hmm.
Well, the graph of r equals 0 is not very interesting. That's a single point.
Yeah.
So we're not real concerned with that one. But this one here is pretty interesting. That means that r equals 6 cosine theta plus 4 sine theta.
Mm-hmm.
There's your polar equation. And that happens to be a circle with a center at 3, 2.
Huh.
Now what's interesting is that that's a circle and not a ellipse.
Mm-hmm.
What was the first problem? What was the problem you gave me that I couldn't figure out how to do?
Let me see.
It was this one right here. X equal 4 sine of 2 theta and y equal 2 cosine of 2 theta.
Yeah.
And we have to figure out what the xy equation is, right?
Mm-hmm.
I still don't know how to do that. Because I know if this coefficient's the same as that, the way to solve this is to square both sides and add the two equations. But that doesn't get me anywhere when I do it here. So I'm still going to have to look at that later.
Okay.
Do you have any others, Griffin?
No, I kind of just need a little bit of a refresher.
All right, let me write that one down. That was, I'm sorry, what was that again? X equals 4 cosine of 2 theta or sine of 2 theta?
Sine.
Sine. I want to look at this and see if I can figure out how to solve this. Now y equals 2 cosine of 2 theta, right?
Yeah.
If I figure this out in the next half hour, I will call you or something.
Okay.
But otherwise, good luck.
All right. Thank you.
All right. Bye-bye.